Okay, so today we're looking at acid-base properties of salt solutions. Okay, so not necessarily an acid or a base, but an ionic compound that can create an acidic or basic solution. Okay, so just to review, when we say the term salt, really we're referring to any ionic compound. Okay, so I know the one that comes to mind when we think of salt is usually sodium chloride, but really a salt is a generic term for something that will completely ionize or dissociate in water. And more specifically, a strong electrolyte, and it's made up of ions. So most of the time when we talk about ionic compound solutions, we don't really refer to them as being acidic or basic. So most likely up until now, you've assumed that they are neutral solutions, right? It's not an acid and it's not a base. But what can happen is some ions, when they are in solution with water, can actually have a reaction with water. So meaning you can have either the positive ion, so the anion is the negative ion, cations are positive. But you could have one of your ions react with water, you can have both of them react with water, or none of them reacting with water. So essentially, the answer to the question on if you're going to have an acidic, basic, or neutral solution here for salts is you have to really look at the ions that are involved. So that's really the goal for today. We're going to talk about, well, how do we know when ions have this hydrolysis reaction with water, and how do we know when it doesn't, and what happens if they do? What's like the next step? So I've kind of already mentioned this. So sodium chloride, right, is an example of a salt that when it dissolves in water, so remember, anytime you have something that is dissociating, you have them splitting into their ions, right? So sodium chloride, when it's in water, are sodium and chlorine ions. So this is an example of something that will have a neutral pH, or a pH of 7. And we'll talk later on about why that is. So some salts, such as sodium carbonate, this should actually be a solid, right? So you're dissolving this in water. So sodium carbonate produces sodium ions and carbonate ions. So this is an example of something that does not create a neutral solution. So in sodium carbonate's case, actually what's happening is the carbonate ion will react with water to produce bicarbonate, but more importantly, what's affecting the pH is it's also producing hydroxide ions. So even though sodium carbonate is technically not an acid and not a base, because you have an additional side reaction happening between carbonate and water, we will have a final result of a basic solution. So that's the goal for today, is like, well, how will I know that this is doing that? Okay, so just keep in mind, I'm going to say this quite a bit. Whenever you have an ion reacting with water, right, that's called a hydrolysis reaction, or we can say that the carbonate in this case is hydrolyzing in the solution. Okay, so how can we predict what is happening? So first of all, you must dissociate the salt. So we already know that, right? So you're going to take your ionic compound and we separate it into the positive and negative ions. So let's look at the cation. So we always look at the positive ion first. I guess, to be honest, it doesn't really matter the order. I guess we're just going to talk about the positive one first. You have to look at both. So the positive ion will hydrolyze and create an acidic solution if one of these two criteria are met. Okay, so the first criteria is that the cation has to be a conjugate acid of a weak base. Okay, so not a strong base, but a weak base. So an example of this is the ammonium ion. So ammonium ions, the conjugate of this would be ammonium, which is in fact a weak base. So because ammonium is the conjugate acid for a weak base, that will tell us, okay, yes, my NH4 plus will react in water and it will create an acidic solution. Okay, so that's one criteria. So let's say this criteria is not met. The other option is if you have a cation with a charge of +3 or more. So +4, +5, whatever it happens to be. So for example, aluminum ions, right? Aluminum ions are +3, iron 3, lead 4, right? So as long as if you have a charge of higher than or 3 or more, you will create an acidic solution. So let's say none of these criteria are met. What that would mean is that the cation is not hydrolyzing in water, okay? So just to give you an example of what would happen then, so let's say we did have a hydrolysis happening. What you would do is you would take your ion and you would react it with water, okay? So we would have our ammonium and water. So ammonium, remember, is behaving like an acid. So what ends up happening here is we end up with NH3 as a result, and my water has now become hydronium ions. So it's actually the formation of the hydronium that is going to cause the pH to be acidic. Okay? So it's not enough just to say, oh, it's going to make an acidic solution. Whenever you are saying that, you should show the hydrolysis reaction, like the equilibrium that is happening. Okay, so let's talk about the negative ion. So the negative ion, so the anion, will create now a basic solution if, and there's only one criteria that will fit here, the anion must be the conjugate base of a weak acid. So not a strong acid, a weak acid. So an example we have here is fluorine ions. Fluorine ions are the conjugate base of hydrofluoric acid, which is a weak acid. So that actually answers the question over here for CO3, because carbonate is the conjugate base of a weak acid. So if you have the conjugate of something that is weak, you will have a hydrolysis reaction that will happen. If it does not meet this criteria, that means it will not affect the pH. Okay, so let's take a look at that. So let's say we did have fluorine ions. What happens when it's in water? Right, so this is going to take a hydrogen, and as a result of that, the water has now become hydroxide ions. And again, it's the formation of that hydroxide that will give us an overall pH being basic. Now, what happens if your positive ion and your negative ion don't meet the criteria? So they both have no effect. That's where you would have a neutral solution. Okay, so let's look at our sodium chloride. We said sodium chloride was neutral, right? So we have sodium ions and we have chlorine ions. Okay, so sodium ions are not a conjugate acid of a weak base, and it does not have a charge of 3 or more. So sodium ions will have no effect on the pH. Chlorine ions is a conjugate base of HCl. HCl is a strong acid, which means that this will not have a hydrolysis reaction at all. Remember, it's only when it's the conjugate of a weak acid or base where you will see that reaction. So because sodium and chlorine both have no reaction with water, it's going to stay as a neutral solution. Okay, so you're probably wondering, well, what happens if you have both of them reacting? So maybe my cation and my anion are both hydrolyzing in water. So what you would then have to do is compare the Ka and Kb values for those ions. So the Ka for your conjugate acid and your Kb for your conjugate base. Or if you want to think of this as the Ka of your positive ion and the Kb for your negative ion. Whichever one is the larger value of the two really will tell us which hydrolysis reaction is happening more. Remember, the larger the K value, the more product you have. So if the Ka value is larger than Kb, that means that we are producing more hydronium than hydroxide. So we will have an acidic solution. If the hydroxide is being produced more than hydronium, it's going to be basic. And if they are relatively close to each other, okay, so meaning the concentrations are about the same, then you're going to have a neutral solution. So we will do an example of comparing Ka and Kb values so you can see how this would work. Okay, so let's look at our first example. So we have predict whether ammonium nitrate will hydrolyze and determine whether the aqueous solution is acidic, basic, or neutral. So basically, remember what this means is it's saying, will this react with water? Okay, so let's take a look. So first things first, we need to write out our compound and our dissociation. So we have ammonium ions and we have nitrate ions. Okay, so this is where you're going to think to yourself, are the criteria being met? So our positive ion is, so NH4 plus, this is the conjugate acid of a weak base. So remember, the weak base that it is the conjugate of is ammonia. Nitrate is the conjugate base of a strong acid. So this is why it's important. You have to know which ones are the strong acids. So when you're comparing this, so nitrate is the conjugate for nitric acid, which is one of our strong. So our NO3 ions will have no impact on the pH, but our NH4 plus will. So the answer here is yes, ammonium will hydrolyze. So we would write out our reaction. So anytime the answer is yes there, you should be writing out your hydrolysis reactions. So this is going to be making NH3. It's actually the same example that we had done earlier. So what ends up happening as a result is we are going to have an acidic solution because we have a hydronium that is being produced here. Okay, so let's look at our next one. So we have here ammonium phosphate. So it's the same thing, just a different compound. So we have ammonium phosphate that will hydrolyze, or we're predicting if it will hydrolyze and then determine if it's going to be acidic, basic, or neutral. Okay, so let's start off by looking at our dissociation. Phosphate is a charge of 3. So we are dissociating that. Now, when you're doing this, you may have coefficients here. That really does not have an impact. Really, we're just trying to answer the question of will this react with water and change up the pH or not. Okay, so NH4 plus, the cation, we already know will have an impact, and actually the reaction is going to be exactly the same as this one here. So because it is, so why is that happening? This is the conjugate acid of a weak base. And we're going to look at PO4. So PO4 negative 3 is the conjugate of HPO4 negative 2. This, in fact, is not a strong acid. If it's not a strong acid, it's automatically assumed to be weak. So here's a situation where we have two that are both going to be hydrolyzing. Okay, so how you're going to approach this is you would first write out the hydrolysis for each one. Okay, so my NH4 is going to be pretty straightforward since we just wrote it out. So we have NH4 plus water, which will be making NH3, AQ, plus hydronium. Okay, and then we're going to have PO4, negative 3, reacting with water, making HPO4. So just a reminder, you only move one hydrogen at a time for these equilibriums, and then this will result in hydroxide. Okay, so we have both equilibriums. One's making hydronium, one's making hydroxide.